Now it is.
Okay. All right, to Jonathan and Morgan, we just announced that there's going to be a test on everything that we've studied from the last test, and that will be on next Tuesday, a week from tomorrow. So put that on your calendar and start studying. We just went over in review, the derivatives of the arc functions, the inverse trig functions, and we found some errors in what I had told you on Friday. So this is the correct one, this was correct, this was correct. This one was not correct. So if you would copy it down and correct yours. If you had that on your homework and you've already done it, just make a note of that. I will not take off for that. What did we have different here? Aaron, do you recall?
I think it was a square on the bottom.
This A wasn't squared. Okay. Just make sure that A is squared. So I must have written it too fast on Friday. And then down here, the last one, I don't know if you can even see it, but the arc cosecant that I gave you was negative. Everything else in it was correct. So we shored that up, and now we're taking it from there. We're leaving derivative land, although we'll use these somewhat. I'll leave them up, and we'll go over to integral land. So we're going to look for 6 more formulas. I was looking at your formula sheet. It was looking pretty poorly. So we're going to add 6 more. Did your arc ones get into your formula sheet? All right. Correctly, I hope. All right, let's take the fact that the derivative, this doesn't have to go in your formula sheet until I say, the derivative of the arc sine of some expression in x, which I'll call u, over the constant a, and that's what we did on Friday, and it turned out to be 1 over the square root of a squared, which is a constant squared, minus u squared, followed using the chain rule by the derivative of that expression u. So guess what I'm going to do to find the integral? What do I always do when I switch from derivative land to integral land? Do you know? Aaron, what do I do to develop it? Since I need an integral, what am I going to do, do you suppose? Any ideas, Brendan? What am I going to do? I've done it many times, several times, a few times in front of you. Gianni? Yeah, take the integral of those sides. Right.
Wow.
In order to study the integral, I have to have an integral. I start with a truth from Friday. I just take the integral of both sides.
Look at different lines.
So when I do that, notice that the integral of the derivative, these are inverses, so all we get left is arc sine of u over a equals the integral of 1 over square root of a squared minus u squared du dx. So, looking at that, it doesn't seem like it would be very helpful, but that is exactly going to go on our formula sheet. I'll call it du. When I go behind the integral sign, I just use the du. It still represents the derivative of the expression over a squared minus u squared. So all I did is I've taken this, instead of leaving it on the right side, I've moved it over to the left side. And it equals 1 arc sine of u over a plus c.
Incredible.
So that is the actual formula that you're going to need to do some of these today. But remember how it always is in integral land. It's just always aggravating in this way, that you have to have this exact form. Remember, whatever is the u down here, notice it's squared, so whatever's sitting here in your mind, to find u, you'll take the square root of it, and then the derivative of that u will have to sit there, and this will have to be a constant, and there'll have to be a square root and nothing else. So it's got to look just like that to be this answer. So you've been in integral land enough to know how it works. So these will take a little getting used to, but they really aren't any different than what you've done previously. So I'm not going to develop the rest of them. I'm going to give them to you. So let's do the next one. I just list them up. If anyone has is the integrals on that page too? Brendan?
I don't see any. It just says basic differentiation.
Oh, really? All right.
Yeah.
Somewhere.
Is it the next section, you think?
Somewhere. Why don't you check, because I don't
Oh,
want
yeah,
to
it
put
is.
Okay. Check mine as I put them up, because I don't
Alright.
want to have any mistakes. Because arc sine and arc cosine are exactly the same, except for that sign, S-I-G-N, the negative sign, we're not even going to use the arc cosine form. Because all that would be different would be a negative here, and then the arc cosine here. So we just are going to use one from each pair, and it'll get us through all of our work. So let's see, the next one is going to jump down. We're going to use concepts from the arctan, and it looks like this. The integral of 1 over u squared plus a squared du. And I like to think of the du following the expression, because that's how I do it in my head, but if you look at formulas, they often put the du in the numerator, so and it's equivalent, and that's going to be the arctan. I think, is it 1 over a?
Mm-hmm.
Arctan. And I could have shown you where that came from, so if you're dying to know, I will show you in private. It just takes too much of our time as a class. So, is that one right, Brendan? Did you check it?
Yeah, it
as
is.
I went up. And the last one, again, we could do our cosine, but it would be exactly the same except for a negative sign here and a change here. So we'll just stick with this one. And the last one involves the arcsecant information. And it looks like this. The integral of 1 over the absolute value of u times the square root of u squared minus a squared du equals 1 over a arcsecant,
Miss Powell.
absolute value of u over a plus c. Yeah?
In the book, they don't have the absolute value.
Really? Woo! In the answer or here,
They have it in the answer.
but they don't have it here.
Mm-mm.
All right, thank you. When we're dealing with these trig functions, you recall that certain arcsine was defined for certain quadrants, as I started that out at the beginning of this section. And this absolute value will release us from checking that. So it's actually a very helpful thing to have. All right, so let's go ahead and see how this works. Brendan, they all check out? I don't want any mistakes.
Yeah.
So check and double check. All right.
Double check.
Thank you. All right, let's go ahead and do a couple examples. And how we should have timed it. We think that was 10 minutes or
I have
so?
it here.
Okay.
It's 8:17.
Okay, all right. So around 12 minutes, we'll break and start again if we're not done by then.
All right.
All right, I'm gonna move these around so I can have some room to write. Yet I still want them up, so just have a dramatic pause here. No tissues either. Maybe I'll steal this one. Nobody used it the other day. Do you remember that one homework lesson we did and it was in integral land and it took 2 days? Do you remember that? It's been a while.
I don't know.
You don't know.
I don't.
Do you remember it?
Not
So
really
we
recalling.
went into integral land and I signed the homework and everyone came back and said, I have so many questions. Blah, blah, blah. And so then we went over them and I said, we'll do another day on these. You don't remember?
Oh, I
You
think
don't
I got you.
remember? Okay, look at me with blank stares. Go ahead. All right, so
Morgan and John probably remember.
okay. Well, anyway, And then we did them together, and then you went home and I gave you like the same problems again, except maybe odd when you had done even or something like that, and you got them all. So this might be one of those kind of lessons.
Oh, jeez.
So, but it may not, because you went through that before and you figured out how to do it, and it's a lot of the same skills. So integrals seem to be a little more challenging when you first approach them, and then they become old hat. All right, so I'm going to put these up again. Just moved
That's
over.
the time.
Why don't you, I don't think you can pause it. Never mind, because, and watch me make sure I got them up here right.
Let's go.
And the last one, at least to do all of ours, we only need 3 of them, so that, at least that. And you said there was no absolute value there, huh? I was
No,
using another text at home, so, oh well.
Did you say you wanted me to stop the video at 12?
No, yeah, is it 12?
It's 11.
All right. Let's see if I can actually do 15 online, so let's see if I can get one example.
All right.
Okay, if not, we will stop it. All right. Again, in these examples, I'm feeding you all the tricks that you're going to need for this lesson. So write them down, make sure it's clear, and see that you'll be able to do it as well. All right, the first one that we're going to do is a little more straightforward than the next. So dx over x square root of 4x squared minus 9. So that is not one that you could normally do with U substitution in the normal old way, where you're looking for the power rule to come out, or ln of x, and when the top's the derivative of the bottom. It won't fit anything that you've done so far. And you got to get good at remembering, well, that looks just like which one of these over here. Definitely not that one. It doesn't have a square root in the bottom. And since there's a variable out here, looks like this one. Do you see that you're going to have to make that determination first? So we're going to go over here and observe the similarities between the setup of this and the setup of that. So when we do that, what is going to be A, do you suppose? Aaron, on this one, can you find what you think A is?
Would it be 3?
It is. So whatever's sitting here in the constant position, take the square root of it. And sometimes they put a number like 5. So guess what your A is? Square root of 5. So be warned. Brendan, where do you think the U is?
4x.
Yeah, that's a,
X.
you said 4x, but we want this whole term to work together. So what's the square root of that whole term?
Huh?
What's the square root of 4x?
Oh.
I mean 4x squared. What's the square root of 4x squared?
2x.
What'd you say?
2x?
Yes, all right. All right, so now you might have guessed wrong because you saw, maybe you were thinking in your head, well, maybe U is x because it's sitting here.
Yeah.
I would recommend with your training to use that. It usually comes out if you use the square root of what's sitting there. So now we have to figure out how to represent the x. So, and we've done this before. So we can see there's an x sitting here. So to find out what x equals, we divide those sides by 2. So when I set up these parameters, I sometimes box them, and there they are. So the only difference is we've got an a to find, and usually that's the quick one. There's usually not much trickery about that. All right, so now I'm ready to set up the problem, and I've got everything I need. Oh, I forgot du, so back to you. Aaron, what's du? No, we were working with Brendan on this. If u is 2x, what's du?
2.
Right. All right, so now I see that my a, is when I square it, is going to be an exact match. My u, when I square it, is an exact match. I can put x here as u over 2, And the dx is right there, so we need that 2. It's missing. So just like in your old integrals, you stick in a 2 and you adjust for it by a 1/2. Now this 2 does not show up in the answer, but this does. All right, so now I don't tend to go back and write it all in U, but I will for training purposes. So 2 dx is your du.
This pal.
1/2 is time. All right.
Yeah.
All right, go ahead. We'll see you on the